Right, hi everyone. In this video we're going to be talking about restricting functions. Um, Now, the point of restricting functions is that there are some things you can only do under particular conditions. One of those things is create an inverse function, which I'm going to be explaining in my next video. Before we can do that though, we need to understand how we can restrict functions to become different types of functions. So here I've drawn 4 graphs, and they're not necessarily functions. Some of them are just relations, but are not functions. So for example, this second one here is not a function. You can tell because if you put a vertical line through it, these 2 points have the same x value, but different y values. And so that is not a function. It is a relation. It's a relation, but it's not a function. So that is not a function. And hopefully you can spot the other one that's not a function. It's this one here. Again, it fails the vertical line test. So that is not a function. Okay, so these 2 graphs left over, they are functions, but they're particular types of functions. They're functions that are called many to one because they have many different x values, so like this value and this value, that both give the same answer for y. So there's many x values that give one y value. Similar here, this x value and this x value both give the same y value. So basically any graph that is symmetrical in that way, symmetrical across the y-axis, is many to one. Now, a lot of the time it's really helpful to actually restrict these functions to make them one to one, so they're no longer symmetrical. So an example of a graph that is already one to one is a linear graph. For every x value, there is its own y value. So that x value only happens once, and the y value only ever happens once. Another example would be a hyperbola, something like this. Once again, every x value only happens once, and every y value only ever happens once. So that's a unique point for x and for y, so it's one to one. Now, if we want to make this first graph one to one, what we've got to do is we've either got to get rid of this half of it, or, if we want to, we can get rid of that half of it. And now it's one to one. And similarly with this graph, we can either get rid of this half of it, or if we want to, we can get rid of that half of it. And now it is a one-to-one graph. So to restrict a function, suppose this function here, it's got the equation of y equals x to the minus 2. Or written in function notation, that's f of real numbers being mapped to real numbers. Here, real is the codomain. If you wanted to, you could say r plus if you wanted to, because that's still the codomain. It contains the range. And then put down the rule of f of x equals x to the negative 2. Now, this function will give you this. If you want to restrict it, suppose I want to restrict it so that it looks like that, and now it's one to one. So this graph here is now one to one. Suppose I want to do that, I have to restrict the domain. So now it's only the positive values that I'm using, so I can do it r plus to codomain is r because the range fits within that, and then I write the rule. So what I'm doing is I'm restricting the domain. It's no longer r, now it is r plus. Or I can write the exact same thing in this way. It goes from 0, not including 0, to infinity. It's mapped onto the real numbers. X equals x squared. Now, some of you may have noticed I've made a very small error, I guess. Here, the domain's not necessarily the real numbers, actually, is it? It's the real numbers except for 0. So sorry about that. This should have been real numbers except for 0. Anyhow, that's basically all there is to it. Like, I could do this one as well. So let's say I wanted to change this so it's like that. So now it is 1-to-1. Let's give myself a little bit of extra room. There we go. So I'm restricting this so it's like that. So it's a 1-to-1 function. So normally the equation would look like this, y equals x squared. Or if I have it restricted now, it's now only the negative numbers. So I'm going to include, whoops, doing this the wrong way around. So it goes off to negative infinity to 0, but it includes 0, gets mapped to real numbers, and f of x, the rule is f of x equals x squared. So there we go, that function has now been restricted.